Previously on Retro Hack Shack.
On a recent episode on my second channel of E-Waste Wednesday, I discovered this TRS-80 Model 4 sitting amongst a bunch of CRTs ready to be shredded. Well, I ended up taking it back and found out that it seemed like it was actually working. And before I could thoroughly test it, I broke the back of the CRT putting the case back together. Well, today it's time for vindication. I'm going to be doing an LCD mod to this TRS-80 Model 4, as well as taking a look at all of the disk drives and making sure those work, and unfortunately falling victim to RIFA Madness. Hey, we've got magic smoke. It's coming up right now on the Retro Hack Shack. All right, so to start with, we need to take a look at the schematic and figure out what kind of signal is coming out of the TRS-80 Model 4 and where those connections are going to be located on the board, or how we can tap into them, right? So I'm using this version of the technical reference manual that has the yellow graphic or whatever, this background here. And this one had a really good quality schematics in it. One nice thing about this is there's really good explanations or theory of operation on how all this works. So we can definitely get some really good understanding of how the video circuitry works here on page 19. This section explains, a lot about how the video circuitry works. It tells you what circuits and what chips are involved and how the data makes its way through several circuits and then out of the endpoints of the video and how things are generated. It's really good for the CRT, but what we need to do is we need to find where these signals actually go into or would have gone into the CRT. And so to do that, let's take a look at the schematic. But I would recommend reading the theory of operation behind the video. It'll really tell you a lot about how TRS-80 Model 4 works and how the video circuitry works. And there are several schematics in here. So this is not just one schematic for the entire system. So you kind of have to look around, see if you can find the schematic you're looking for. This one is not the one I'm looking for. We're looking for something that has video on it, or horizontal sync or vertical sync. That would lead us to presume that we have the right schematic so that we can figure out what we're looking at. Okay, here we go. This looks pretty good. So I noticed on the bottom of the schematic here, it says video RAM and video interface. So that definitely keys us in that this is the schematic that we're looking for. And we can just kind of hunt around and see if we can find, like I said, anything that says a horizontal sync or video. And yeah, here it is right over here. Let me zoom in on this. So it's kind of hard to see unless you actually take a close look at it. But the thing that clued me in at first here was this VS and HS right here. So that's going to be the vertical sync and the horizontal sync. Like I said, sometimes it's labeled different things on the schematic, so you kind of have to be able to read into the way that it's written here to figure out what it is. Sometimes it's V and then sync, the word sync, H, the word sync. I've seen that before. But in this case, it's just VS and HS. And then also down here, this is all part of jumper 5 on the board. Down here, we see that there's a VIDI out. I don't know if they forgot to put the O, or they just, somebody was, I don't know, making up a word here, VIDI out. But yeah, seems like there should be another O in here. But this also on jumper 5 makes sense that there would be a video pin. So now we know what we're looking for on the main board. We're looking for horizontal sync, vertical sync, and a video signal. And we have what pins that's going to be on right here. The video is going to be on pin 2. Vertical sync is going to be on pin 4, and horizontal sync is going to be on pin 6 of this jumper or pin header right here, J5. All right, well, now that we've taken a look at the schematic, let's take a look at the unit itself and see if we can find where those connections are physically on the board. One way to do that is to start with the connector that was going over. This was plugged into the CRT board. Of course, the CRT is gone. This is the back of the computer. The CRT was facing that way, so I've kind of turned this around so you can easily see what's going on here. But on this connector that's going to the CRT, if you've done this for a while, you'd probably recognize the lines that are for horizontal sync, vertical sync, and the video signal itself, because a lot of times they use these cables that were shielded, and you can see there's 3 of these. They kind of look like coax cables where they have another protective sheathing in the middle here surrounding the middle conductor, and then they have this sheathing, or the shielding rather, that in this case they've peeled back and joined together, and that goes over to the ground connection on the case. But if you see these, a lot of times these will be the signaling for the video signal that you need for the CRT. They did it that way to protect those, shield those a little bit, but I don't know how well they actually work at the end of the day, because you're leaving all of this exposed, and of course the whole board on this side would be exposed to interference. But anyway, be that as it may, they're pretty easy to recognize. So what I did was I just followed these, of course, back up through the cable, and they end up here. This connector was connected right there, and I could see that those 3 signal cables were coming up to there, and they do match up with the order that we saw on the schematic. There's a blank there, so that would be pin 1, and then we have pin 2. Pin 3 has nothing. Pin 4, which is the vertical signal, and then an empty one, and then on the 6th position there is the horizontal sync. So we've got video, vertical sync, horizontal sync on that connector there. I've taken that off, and I've also found that this red connector here goes over to the power supply, and that is the 5-volt line, this red wire right here, and the brown wire is ground. So I have the sources that I need actually now to hook up the RGB to HDMI, as well as a source of power. Now, I did go ahead and look at the power supply here. The good old Aztec power supply has, on the 5-volt rail, it actually has 5 amps of capacity. So that is actually really good, because we should be able to hook up the Raspberry Pi directly here, and that will allow me to power the Pi directly from the board without having to install an additional power connector. So the next thing I had to do was take the motherboard off so that I could get at the pin connectors where they connect to the back of the board here, so I could solder on this cable here, which I'll talk about in a minute. But if you've never worked on a Model 3 or a Model 4 or any of the other Tandy products, they are kind of a weird architecture physically, and they're kind of a pain in the butt to take apart. There's a ton of screws, so I've got screws spread out all over my shop at this point, and they put the board in vertically like this. I don't know, it's just a kind of an odd arrangement compared to all the other computers that I've ever worked on. Plus, they also have connectors coming in at weird spots. They have this kind of power connector here coming over to the motherboard. They have the video connector over here. Down here, they have a cassette connector, and then they have connectors for what I assume are going over to the floppy drive controller, and they are these flat ribbon connectors that often become delaminated. Luckily, these look like they're in okay shape. They're a little crinkly and a little stiff, but I think they're going to work just fine. And then all the way over on this side, you can't really see it. There's other connectors for the keyboard, and I'm not exactly sure what this one is. Maybe that's another power connector just for redundancy, or maybe to power this side of the motherboard. But yeah, the whole thing is a little janky. And of course, we have all of these. They might be bodge wires, but I don't think so. I think these are actually taking voltages from, one part of the motherboard over to the other. This is probably 5 volts and 12 volts here, something like that. So the whole thing's a bit janky, but it does work. And it's just a different architecture that you have to get used to. The other interesting thing to me as we're at this angle is you can see the memory down here on the board, and then you can see all of this logic. This is the gate array version of the Tandy Model 4. Another thing I noticed here, which was interesting to me, is all of these ICs over here, there's not a lot of passives, and then over here in the video section of the circuit, I believe, are all of these passive resistors and things going on. So just kind of an interesting layout, a lot of passives here, and then just the rest is mostly ICs with decoupling capacitors, etc. And these cables that I connected will need some support, probably some tape or something like that I can put on there to add some strain relief, because these little thin ribbon wires actually break off quite easily. So I'm trying to be delicate with those. And then of course I have those attached to the RGB to HDMI device that I sell on my website through the ribbon cable right into the CPLD board here. And if you're thinking about doing this yourself, I will put the connections of where they go using this 12-pin ribbon cable that I'm using You could also use the 9-pin connector, D-sub connector that you would find on the TTL board, the same one that you would use to plug into a PC. If you want to do that, though, that does not have accommodation. There's no room for the power connectors. That's why I went with the 12-pin digital cable that I sell on my website here, because now I can actually feed power directly into this. And since this is going to be hidden away somewhere in here, when I figure out where to put it, I need to have this thing power up by itself every time that I turn the computer on. So don't want to have a separate power cord for that, and this is perfect. There also is a profile built already in the latest revision of the firmware for the RGBtoHDMI, which I was glad to see. I wasn't sure if there was going to be. There are profiles for the Tandy model, TRS-80 Model 3 and TRS-80 Model 4, which this is. I think those were donated by the community, so thank you to the folks in the community who worked on those profiles to get them working. So I have that all set up and ready to go now. I'm going to do a screen capture so I can show you what this looks like. But what I expect to have happen when I power this thing on is for this to come on and then give me hopefully a good signal now that we've got this part figured out. One other thing I should note is that by soldering these wires onto the back of the connector here, this is easily reversible if I did want to put a CRT back in. In fact, I could leave this plugged in if I wanted to. I probably will once I put this back together, but I can leave that plugged in and make this completely reversible, or I could even leave both of them connected and just have a HDMI out of the back of this thing if I wanted to. That's another option. So this would also work if you wanted an HDMI mod for your Model 3 or Model 4, but you wanted to keep the CRT in place as well. So keep that in mind. Okay, I've got everything plugged in. I think I can go ahead and turn this on. Here we go. And yep, I can see the RGBtoHDMI device looks like it's got a signal. It's trying to lock on there. It's got the little blinking light down here, which is trying to negotiate. It's solid. So let me do break and reset. It looks like this is working. If I hit enter twice, enter, there we go. Now I can sort of see actually. Yeah, so I'm getting, everything looks to be hooked up correctly, but the screen, it does not look right. It's got these kind of vertical lines going through it. So it's not pretty, but it is working. So good news is, looks like we've got the horizontal, vertical, and video all going into the correct inputs in the RGBtoHDMI. So this is a success, but the image itself needs to be cleaned up a bit. All right, well, I have been playing with the settings on the RGBtoHDMI now for a half an hour or so, just trying to see if anything that I could put in there would change the image quality. Because what I'm seeing is like these vertical dark voids that go down very regularly through the letters, and it's making it almost unintelligible to read the characters on the screen. Now, what I did was I went out to the support forum. If you don't know, if you buy a product from me, I don't support it directly in other than, hey, my board's not working, I need a replacement or something like that. But in terms of, getting a particular computer to work, I lean on the community to help support that. And you can go to the support thread on the Stardot thread. I'll put a link to it, or you can look on the shop page on my website, has a link to it. And that's where folks hang out to help other people either create a new profile for a new machine or figure out what's going wrong, et cetera, et cetera. So I went to that forum, of course, and did a search for Tandy Model 4. And what I found is that there was a post there from a person named Filf, or whatever. I think I'm just going to call him Phil to make it easier on myself as we go through this. But he was fortunate enough to try to hook this up and create a profile for it. And he found the exact same problem as we're seeing here with these lines. And what he discovered is that there was some interference in the video signal coming from the dot clock. Now, the dot clock is basically a clock that helps synchronize the video signal to the CRT board so that it draws the pixels on the screen for each character in the proper order. Well, in this case, there seems to be some sort of interference that the dot clock is actually injecting here into what would normally be picked up and dealt with the CRT board is not being dealt with correctly here by the RGBtoHDMI. And it's creating these lines that the dot clock is kind of interfering with the ability to create the screen the way that we would want it to be created. All that to say, Phil on the forum discovered that you can bypass the dot clock by picking up the signal in front of where the dot clock is. So if we actually insert the video signal just slightly before where it comes out up here at the top of the board, we should be able to bypass that dot clock and get a clean image. So let me go ahead and hook up a wire and see if that makes any difference to the way that this image looks on the screen. All right, I've added some fresh solder here to pin 13 of U24, and I've hooked up this little bodge wire. It might be hard to see because it's exactly the same color as the solder mask here, but it's just a piece of scrap that I had laying around. Now I will connect the other end of this to the video signal, which I've disconnected from that connector, and I can just use the old heat gun to shrink this tubing down. And here's what the final product looks like. Hopefully you can see this green wire coming over there and going up to the, now it goes up to the video signal, where the video signal used to be attached back there. Now goes through this bodge wire here. In case you're wondering, U24 is right over here. So you just have to find pin 13 on that, so you know which pin to connect to the bodge wire. Before I get too far in the weeds with these mods, I just want to take a second to thank the sponsor of this episode, PCBWay. PCBWay offers low-cost, high-quality PCB manufacturing and a whole lot more. They offer flexible and rigid-flexible PCBs. They offer surface mount assembly. They offer high-density PCBs with up to 60 layers. They offer aluminum PCBs, and they also offer custom metal and plastic parts that need to be CNC milled or 3D printed. One of my favorite features on PCBWay's website is their project page, where the community can upload projects. You can browse these and order these particular parts so that you can use them yourself. Or you can create your own project by uploading your design and receive 10% back when someone else orders your particular project. So check out PCBWay for all your PCB manufacturing needs, and I thank them for their support of the Retro Hack Shack. All right, well, as you can see, things are looking a little different now. I'm ready for a test of the new bodge wire we put in, and for that I went ahead and hooked up my laptop, which is also hooked up to the capture over here now, so we can see it instead of just a screenshot. You can actually see what this looks like. It's kind of funny that my tablet PC here actually fits almost in the full width of this space here, but it's only, what, like 10 millimeters, maybe 8 millimeters thick here at the back. So that's kind of funny. The depth is so much different. It's funny to me anyway. New technology and old technology working together. All right, let's turn this on and see what happens. Okay, it is on. Oh, that's good. That's the Raspberry Pi. It always does that when you boot it up. So it is now trying to get a signal. It's telling us that this is 1920 by 1080. And if I do break, reboot, hey, there we go. Cassette. That is exactly what you would expect to see from a working TRS-80 Model 4. So if I hit enter, yep, memory size, hit enter again, it's going to go through and count up the memory. And there we go. This is looking great. No more vertical black lines breaking up the text. Now I can see this very clearly, and it looks fantastic. Crystal clear HDMI quality output from the RGB to HDMI hooked up to the TRS-80 Model 4. This is awesome. Let's just do a quick program. I do want to make sure that the keyboard is working, because there's another one of those janky cables, those flat flex cables that were so bad back in the day. There's another one hooked up to the keyboard going to the back of the motherboard there. So I just do want to make sure that everything's working. So let's just do a little program. 10, print Retro Hack Shack, and then 20, go to 10, baby. All the keys seem to be working, at least the ones that I've typed so far. Let's go ahead and run this. And there we go. Retro Hack Shack in all its glory. This thing is looking awesome. All right, let's just see. Well, I've got this hooked up. Let's just see if I can get the disk drives working, because right now I'm waiting for the actual display, which will go in the case, which is sitting just off screen over there. The actual display panel I'm going to use for this is still on its way from Amazon. So let's just see if we can get either a game or some sort of word processor or something running on this thing. All right, well, I finally found my discs, and this one is not made for the Model 4. This is actually made for the Model 3, but I think it will boot. And so really that's what I want to try to do, is see if this will boot and then see if both drives are working. By the way, this is a reproduction label I made, which should look very, very similar to the original label that was on the original disc. I spent a while making these, and it was a lot of fun. I really do have fun in reproducing things. If you notice back over here in some other shots in the video, you'll see the Computer Chronicles sign back there that I made, and I'm looking to make more of those. So anyway, reproducing these vintage things and reproducing them like really, really well is a lot of fun. I really enjoy doing that. But let's go ahead and put in this disk and reboot and see if it actually reads it. Yep, there we go. TRS-DOS Model 3. Oh, that doesn't sound good. Yeah, so it's trying to read the disk. There's obviously some cleaning or something that's needed. The fact that it actually does at least attempt to boot from the disk is a good sign, but perhaps the heads need cleaning, or, you know, maybe it needs a little lubrication or something on the floppy drive itself. So yeah, I'll have to come back to that and clean those and see if I can get something working. I went ahead and took these drives out and gave them a thorough inspection, both the physical and mechanical part of the drives, as well as the electrical part of the drives, to see if there was any obvious problems there, and they both looked good. Since I didn't find any other problems, I went ahead and started lubricating. First, I cleaned off the rails and then applied some lithium grease. I went ahead and cleaned the heads. I checked out the belts to make sure that those had proper tension. I went ahead and added some lubricant as well to the doors of these particular drives, because those can be a little sticky. I also applied a little bit of lubricant to each of the stepper motors, since those seem to be sticking a little bit. And after exercising them back and forth and leaving them sit for about 15 minutes for that oil to penetrate, these drives now seem like they're working just fine. Okay, now I am turning my attention to fixing the power cord, and the power cord used to be back here. There it is right there. And the power cord used to be fed through here and was held on with one of these grommets that goes in there. And what I'm going to do is I want to add a socket here, as I mentioned. And the socket that I want to use is just one of these standard IEC, I think this is a C14 type socket, and that'll allow me to plug it into, you know, any handy power cord that I happen to have laying around, as well as making this a lot easier to carry and store without that cord hanging off. So I want to put this on there, something like that, I think. And so what I've done is I'm going to be cutting this plate, which is why I had to remove it. And I 3D printed this bracket that I found online. So what I will do is I will just mark this out with a marker or something like that in the template, and then I will cut this out with a Dremel, and that should be pretty easy to add this socket on there and make it much easier in the future to move this thing around. All right, well, there it is. At the end of the day, it's not that pretty, but it was okay to be a little rough around the edges. It's about as good as I could get it with the Dremel, and it's a little crooked, but it'll work, I think, once I get this in there. Yeah, there we go. The holes line up. Like I said, a little crooked, but it'll do the job. All right, well, it's time to prepare for the LCD screen, LCD panel installation. And one of the goals for this project was to make this reversible. So if I wanted to put in another tube, I could. And so what that means for me is I'm going to be saving this CRT board and the yoke. I'm going to get that removed. This CRT has been discharged for a very long time now. And so I can just go ahead and pull that off without worrying about shock at this point. But let me get this done, and then I will have to unscrew each of these four corners here, and then the CRT should just come out. Okay, step one done. And there's a little screw here attached to the yoke to keep it in place. So to remove it, all you have to do is loosen up this little screw, and then you should be able to slide it off. There we go. All right, the tube is out. And indeed, I broke the nipple. Nipple is broken. Damn you, nipples.
Damn you! God damn you all to hell!
There we go. Grounding strap is off. And now this CRT can be taken to recycling. Just in time for E-Waste Wednesday. Next step I'm going to have to do is take off this bezel. And interestingly, the bezel is one piece. So I'm going to have to take off all these screws here because this bottom black piece is all connected to this upper piece. And it looks like these are Torx screws. Once I get those out, it looks like this just slides up in there and snugly fits in there once you get everything there, which is why there's so many screws on the bottom part here. And then it also looks like this black part, which is behind the badge on the front of the case, is also attached here. Listen to this crack. You can tell these plastic nuts here have never been removed. Listen. Sometimes when screws crack like that, it's an indication that perhaps they've never been removed or haven't been removed in a long time. In this case, the tension is so tight on these. And of course, these haven't ever been removed from this thing. So yeah, they're making nice big cracks. There's a couple more Torx screws up here that I did not see. Black on black. My eyes are at a point where black on black almost is unseeable by me. All right, well, the badge is off. No harm to the badge, which is good. I did use the hot air gun, heated up especially the back of this badge because it's metal, so it heated that up really well, and just used a screwdriver, not to pry it off and make any dings in the plastic or the badge, but just to put some gentle force, and I worked my way down from the top, putting some gentle force with the screwdriver to kind of get behind the badge and make sure it didn't re-adhere to the plastic. And yeah, took about, I don't know, 2 minutes and this thing was off and is undamaged. And just as I thought, behind that case badge, there are 3 more little Torx screws, which were keeping this bezel from coming off. Here we go. All the screws are out. Let's see if this thing will, yep. Oh, it just comes right off, no problem. I'll save it for later in case I ever need to put this thing back together. Okay, let's go ahead and take a look at the screen that I got. This is an IPS display, and what that means for me is that I'm going to have a really good viewing angle. Basically, it will look good from any angle you look at it. If you were a longtime viewer of my channel and you remember the mod I did on that old, I think it was like a 1976 Sony Trinitron where there was problems with it and I replaced the guts of that thing with a panel like this. The one thing that I wish I would have done is use an IPS panel. In that one, I used a regular TFT panel, and even for a modern display like this, the viewing angles on that are bad. And I really found that out when I was recording some of the Atari videos that I did. I had to have the camera pointed basically directly at or in line with that TFT display to get it to show up on the camera. So what I wanted to do with this, not that it's going to be on camera, but I did want to make sure that I got a nice display that had good viewing angles. So this display is a little bit more expensive. It was a little over $100 when I bought it. I can't remember exactly, but I'll put a link down below if you want to buy one of these. You can find out all the information. It's a pretty bare bones kit, but I did plug it into my Windows computer and hooked it up, and it works great. And I can see everything on the screen from any angle. So it's going to look like a nice modern display that you might use on your laptop or something like that. And I played videos on it. It handles videos great. There's no screen tearing or things like that I could detect. And besides, this thing's just going to have text. So this is a bit overkill probably for this type of computer, but if it doesn't work out or I need to use this for something else, I'll know that I'll have a good quality display to use. I think it's worth the money. Now, the other components that come with this are the control board. This is the main board where the power goes in, the HDMI goes in, and it plugs into the back of the panel here for all of the data processing. And then this little board is for the voltage, the high voltage that you need to power the display. It also comes with controls, which I'm probably not going to use because it also comes with this remote. Now, of course, remotes can be lost, but I don't necessarily want to have to cut through this case to mount these display controls somewhere on the bottom of the case or something like that. I might extend this infrared LED here somewhere on the case where it will pick up the remote for me, and then I can adjust things like contrast and brightness and all the other things that you might want to do. Let's see if this thing is actually going to fit inside this case. Now I know it's going to be off. That's okay. I kind of planned for that. There's no way you're going to match exactly the case opening here with panel. It's just never going to happen. The odds are really against that matching up exactly. But I can see that this thing is just about, including the steel casing around the display, is just about as wide as the opening. And if I hold it like this, maybe you can see a little bit better that it is a little short here. It's about a 1/2 inch off from either side. So I've got about a 1/4 inch to play with on either side here. But the fact that it's a little smaller in each dimension is good, because now what I'm going to do is I'm going to go ahead and 3D print a new bezel for this thing that will not only fit this opening exactly, but will narrow down until it matches up with this screen precisely so that it looks like it was made to fit. All right, well, that design didn't take too long to create. I think I whipped it up in about an hour or so, and actually a lot less time than it took to print these little bits of it. And what I like to do is print just a slice of the print. Instead of printing the whole thing and finding out that my dimensions were wrong, I'll print just the slice that I need to test the critical parts, and then I can go back and make changes so that I don't have to waste all that plastic and be frustrated and wait so long for the thing to print again, because this is going to be a long print, probably a 6 or 8 hour print when it's done. What I have here is those 2 test slices, because I need to check and make sure that the piece of the bezel that's going to sit flush against opening here for the monitor is sized correctly. And I need to make sure on the back end of the bezel where the display is going to be attached that those dimensions are accurate as well. So here's that piece. And as you can see, somehow I sized this way too small. It's off by, on the inner part of the dimensions here where the screen is, it's off by about 4 millimeters or so, I'm guessing. I'll measure this with a caliper when I'm done to make sure. But it's also off on the outer part, and that's critical too, because here's the screw mounts, and if this thing is too short, there's going to be nothing to mount this thing to. So I need to increase both the width and the height of the interior part of this part of the print, and I also need to extend the outside a little bit to cover the mounting holes. Now this piece is the one that's going to go on the inside here and be attached to the face of the case, and then the bezel will extend from there. And I have these rounded corners here, so if we set this on the inside just to see, there's a couple of problems. The first one is that I didn't round the outside corners, and that really only affects the corner up there, but I'll probably just go ahead and round all the corners. And the second problem is that there are these little, I don't know, maybe 2 or 3 millimeters worth of little pieces of plastic that fit into the original bezel, and I didn't account for those when I was doing my print. So I'm going to have to shorten the top of this down a little bit in order to make sure that I can actually fit this snug all the way into the top, and so that this fits in correctly. Because right now it's overlapping the opening here because it's not going all the way into the back. All right, well, here is the bezel all pretty much ready to go. Of course, like with most 3D printed models, when they came out, it had to have some sanding done, and then it wasn't black, even though I had printed it in this black plastic. Once I had done the sanding, of course, that roughed it up and didn't look black anymore. So I went ahead and threw a coat of paint or 2 on this thing, which was fine, but that paint has to dry, putting more delay into this episode, I'm afraid. And technically, this is supposed to wait another few days for the paint to truly cure and adhere to the plastic, but I'm getting impatient at this point. So I decided to let this dry for about 24 hours, and then we'll see how this gets on in just a minute. But in the meantime, what I was working on was trying to polish up some of the finishing details here to make this mod work. I mounted the RGB to HDMI board back here in the back, and I mounted that with some of this hook and loop tape from 3M. This isn't the fabric kind. It's plastic on both sides, and when you put it together, it does snap together really well. And there's the adhesive that 3M uses sticks really, really well to whatever you put it on. And so this will hold really nicely here, and it won't fall off over time or anything, but I can take it off if I need to change anything or whatever. So that's really nice. The other thing I had to worry about was power for the LCD display. And I couldn't use the power supply in the computer. It does have 12 volts, of course, but that 12 volt supply is only rated for a little over an amp in current, and that's already servicing the rest of the board. So I couldn't tap into this and use that because the display requires an additional 2 amps to run. 2 or more amps is what it recommends for the power supply. So what I did was I dipped into my spare parts and found this power supply. This is a 12 volt, 3.3 amp power supply, so it should have plenty of juice for that display, and it's small enough that I was able to affix it here inside the case the same way that I did the Raspberry Pi by using some of that 3M hook and loop. I can't remember the name of it. Maybe I'll put it in the video or leave a link down below. It's really good stuff, and I use it all the time. Holds things really nicely. And then to power this, of course, I'm using the mains. And then what I did here was I just cut off about, about a 1/4 inch of the plugs or so, making this a little bit more like a spade connector. And then I was able to use my large spade connectors, which have these nice protective boots that go over this and will hold that tight. And if I ever do need to revert this, or I want to take this out, replace it with something else, it's just as easy as pulling these things off and putting something else in here. Of course, with those prongs cut, I won't be able to use this for anything else, but that's okay. I was able to reuse something in my spare parts, and so I'm happy to do that. And this should be perfect and nice and out of the way of anything else. Now, one other thing is I want to be able to control the RGB to HDMI, but I don't want to have to go through that laborious process of taking out the 12 screws or whatever it is that holds the top part of the case on every time I want to go in here and make any kind of change. Well, the RGB to HDMI has a hidden feature. Well, it's not really hidden, but it's just not very well documented. And it's called single button mode or Amiga mode. I think it was created for those people who had Amigas and put the card in the video socket in the Amiga. And then like an Amiga 2000, for example, has that video socket on the side and then needed a way to control this from outside the case. And this is going to work perfectly well for this modification that I'm doing as well. So what I've done is the main button or the menu button, the select button, whatever you want to call it, is this one right here. I went ahead and attached some wire and ran that down along the base of the case, out through the side, and attached it to another button right underneath here, which is right in back of these potentiometers that were used for the contrast and brightness. So it's kind of where you would expect some sort of adjustment to be. What this single mode feature will do is if I hold down the button, long press on the button, if you will, it will select something, or if I short press the button, it will go through the menus of the RGB to HDMI. So that will let me control things through here. And that's important because I realized that I might be able to get not just plain white text on the screen, I might actually be able to get amber text and green text. Now there was a green, this was actually the green version of the TRS-80 Model 4. So this had the green screen. The versions previous to this, the non-gate array, or was it the gate array? There was two. There was a gate array version and a non-gate array version. Anyway, one of them was white, had a white screen in it, and the other one, this one, had a green screen. And I thought, why not throw in amber as well? So I'm going to be working on some specialized profiles for the RGB to HDMI that will allow me to switch the color of the text on the screen based on however I'm feeling that day, or maybe someone just wants to see what it would look like. So once this is all together, if I'm successful, we'll be able to go through and see what those look like on that new LCD display. Well, it's time to go ahead and mount the display to the bezel so that I can start getting it ready to put in the case. And to do that, of course, I'm going to need to remove this protective coating. You know what that means? That's right. Let's go ahead and cue the music. Ah, so satisfying. All right, what I'm doing here is the bezel is just about, I don't know, a millimeter or so too wide from top to bottom. And what that means is you can just see this highly reflective aluminum or whatever metal it's made out of, maybe it's steel, I don't know, which goes around the outside edge of the panel itself. And so what I'm going to do to make sure that that reflective surface isn't distracting from the display itself is I'm just going to go around using some paper to mask the panel to make sure I don't get any of this on the panel. Just going to put a little bit of Sharpie around the edges here for, I don't know, a couple millimeters or so, maybe 4 or 5 millimeters. And what that'll do is it'll just make it really just blend into the black of the plastic. And then at that point, I don't think you'll be able to see, or you won't notice that little tiny edge that's creeping out from behind the bezel. What I've done now is I went ahead and put painter's tape, masking tape basically, on all 4 sides of this thing. And then I'm going to flip this over and make sure that everything is exactly lined up the way it needs to be. And once it is, I'll pull those pieces of tape across, try to hold this thing exactly in place where it needs to be. And then I'll go ahead and screw in from the back in place with the tape attached so that it doesn't move around and get either at a weird angle or whatever. Okay, I've got this thing screwed on and trying not to touch it to get my fingerprints on it too much. Touch the screen, that is, anyway. But now it's time to go ahead and fit this into the opening. And again, it has to be lined up you could get it crooked very easily. So what I've done is I've lined the outside of the opening with this Scotch double stick tape. And my plan, hopefully, is to be able to line this up perfectly. One last push to get it to stick to the double stick tape, and then I'll use some E6000 glue to affix probably the corners and some of the sides here and everything, so that it will be stable and not fall off when I'm, transporting it or whatever. If I really wanted this to be permanent, I would use some sort of epoxy or something, but because I want this process to be reversible, this is kind of what I'm left with. The other option would be to 3D print some brackets. I can do that pretty easily for these standoffs on the bottom here. The ones at the top, however, come right down on the top of the display. So it's doable, but it's probably a lot harder. And right now I just want to get this thing done. So I think I'm going to go for this route for now. I'll let this dry overnight, see if it seems solid. I'll jostle it up and down or whatever to make sure that it's going to stay in place. And then we'll hook everything up and see if it works. All right, well, good morning. I am back. I glued this thing up last night. It's always best, if you can, to let this E6000 sit overnight. It does dry pretty well, and I found that in about 30 minutes or so, you're going to have a pretty good bond, but that bond can still be broken with a little bit of force. Once you've waited 24 hours, though, this stuff sets up really well. It can be heated up and removed when you need it to. You heat it up to, 150 degrees or something like that. It'll become soft and pliable, and then you can remove it. But anyway, I let this thing set overnight, and I also went ahead and cleaned up the cables and things like that because I was just waiting for the glue to set, basically. So I've got the high voltage board mounted. I used this dual lock stuff. It's 3M dual lock. I forgot the name of it before, but it's really good stuff. I'll put a link down below if you want to get some. I'll put an affiliate link that'll give me a little bit of money if you click on it. So thank you for that. But anyway, yeah, mounted this high voltage board right to here because I couldn't find a better place to put it. And I mounted the video or the control board here, and with 2 pieces of that dual lock, and man, this is like solid. Like if I push on this anymore, it's going to move the whole case. And I wanted that to be solid so that I could push that HDMI cord up in there without this thing falling off or whatever, becoming dislodged. And then I put the controls for the display over here. I'm not going to be using these that much, but I do want to be able to use the remote, as I mentioned before. So I made a custom cable, and I made it long enough so that I can go underneath the computer and then back up here just underneath the keyboard. And I think that if I position the sensor there, that'll be good enough to pick up the remote control as long as I'm holding it at the right angle. So anyway, I think it's time now for a test. Let's take a couple swipes at this thing and see if it'll hold up to some rigorous motion that I might use if I'm, for example, taking this to a conference, like a VCF conference or something like that, where you got to unload it out of your car, et cetera, et cetera, et cetera. So let's do some tests, see if this thing's going to fall out. Well, I've got it in this angle. Let's try a little poke test, because what I found is that take these things to conferences or even sitting around at home, often people can't resist when they're pointing at something touching the screen. So let's just poke at the display around the corners. Any movement? No, looks like I can poke and touch this thing all I want. Let's step it up a notch. I'm getting this thing out of the car, ready to go to the conference. Here we go. And I'm carrying it in, and I'm rushing because I'm late and I've got to get to my table. And yeah, this thing is not moving anywhere. Okay, last test. I run into someone, they come up and say hello, and I'm trying to get this on the table. Oh, hey there, it's nice to meet you. Oh, you're a patron? Wow, thanks for supporting the channel. Oh no, I'm gonna drop it. Okay, well, that was a pretty good drop. And wow, rock solid. Okay, well, luckily this isn't that heavy, not nearly as heavy as a CRT. And the combination of that double stick tape, which I need to trim off the excess a little bit here, and the E6000 glue is going to hold up really nicely. I'm really liking how stable this is. The drop test, I don't want to drop it any more than that because I don't want to crack the plastic or anything. But this is holding up great. All right, everything's connected. Should be much easier. It's very much lighter. Should be much easier than with the CRT. In there. Tuck these cables in, make sure they go in the right place. So actually the display part is fine, but it's catching on something on the other side now. There we go. That is on, I think, all the way around. It was catching on that little plasticky shielding, I think, that comes up from the bottom. It wasn't really attached to anything and it was keeping that side from going down, but this is on. Got my little remote here. So this looks like it's ready for its first test. What do you think? And just look how black that display is. I mean, obviously you can look at it and see it's not a CRT tube, but I think it looks really sharp. Let's go ahead and plug the power in. All right. First test with everything assembled. Oh, the screen just came on. I forgot the screen is directly connected to the AC. So that's going to happen. Well, let's go ahead and turn on the actual computer and see what happens. And look at that. There it is. Wow. That looks fantastic. Let me just show you. Oh man, this is so awesome. It looks so good. I want to show you a close-up with the camera. I mean, just look how good that looks. And the bezel looks fantastic. I mean, it looks like it was made for it. Well, I guess it was really, but oh man, that display looks good. And the viewing angle, I mean, come on. There's no way. With a TFT, this camera would be like, oh, I can't see that. Now there's some reflection there, but you can still clearly see it. I mean, it's not like the viewing angle is causing it hard to look at that. Oh my word. I'm almost 180 degrees. You can still see it and hopefully still read it. Wow. I mean, that is an upgrade if I've ever seen one. So cool. And I did find that I had to adjust one thing. There was a lot of pressure on the Pi because I was using this adapter in a regular size HDMI after that. It extended this out a little bit too far and there was a lot of pressure here on the Raspberry Pi. So either I could move the Raspberry Pi or I could add a right angle HDMI adapter to fix that. But I happen to find this short full-size HDMI to mini HDMI here, or micro HDMI, I think it is. I don't know. Anyway. It's not the really little one, it's the in-between one. And now with that in place, I think that will work a lot better. In fact, I think what I'll do is I'll just tie this down so that it is out of the way and then won't have any more pressure on the Pi itself. Hey! We've got magic smoke. Oh man. And this does not smell like RIFA. It smells like something else. As I was playing games. I got magic smoke. Dang it. I think this thing is cursed. I guess we'll have to figure out what's going on. Oh man. Not cool. Not cool at all. I'm just sitting here playing a game. Wham. Wham, bam, thank you, ma'am. Ah, what the heck? And yeah. Do you think maybe it was the RIFA cap? Oh, that was probably one of the worst ones ever. All right, time to switch out the RIFA caps like I should have done in the first place. And hopefully everything is still working. We'll find out. Yep, and there it is, folks. That's where all the magic smoke comes out of, and magic smells. Just goes to show you, just because your RIFA caps look good doesn't mean they won't blow. Get rid of those RIFAs, or at least replace them with new ones that'll last another 40 years. Okay, well, now that the RIFAs have been replaced, I just want to make sure I'm going to go ahead and test the voltage. I did test for shorts, no shorts on any of the voltage rails. Fuse didn't blow, so hopefully that means it wasn't drawing too much current and overloading something on the board or on the Raspberry Pi or whatever. But yeah, I just want to test those voltages and make sure they're reading the same as before. So go ahead and apply power to the power supply. And I'm getting a high-pitched click. So that could be that there's not enough draw maybe on the system. So I'll actually go ahead and hook it up and just let's see what happens. Okay, everything should be hooked back up. Let's see if we still get that clicking. Let's see if the computer starts up. Yep, looks like it's starting up. It's reading the disk and yep, it's up. I can see it over here. So no harm, no foul, I guess, except for the smoke and the evil stench that's now filling my garage. All right, with all that out of the way, this thing is finally done. I went ahead and gave it a really nice clean. I reapplied the badge that we had taken off earlier, so that's on there nice and tight now. The case fits on, everything's working, and the screen looks great. So let's go ahead and walk through what this actually looks like. There it is, and we're up and running just like that. Drives are working great now that they've been serviced. They're not very noisy at all. I've also went ahead and hooked up a GoTech so we can play a game in just a minute. Now, one of the things I was kind of curious about is what this would look like with that glass. If you remember from the video on the second channel, when I got this, it had a piece of coated glass. And where did I put that? I said coated. I guess tinted is a better word to use. It's tinted glass was there, and I was kind of curious what this would look like if I put it back on with the LCD instead of the CRT. And you can see that it actually looks pretty good. It does a pretty good job of kind of dimming things down a bit, and it's still very readable and very nice. So I might put this back on since it was obviously custom fit for this machine. I'll probably put it back on when I'm all done for storage, but you don't really need it. I guess it's just a matter of personal preference, whether you like that view a little bit better or what you're used to, or whether you like that view. Obviously a lot less glare not coming from a CRT. But while we've got this off, we can now go and actually put it back the way it was with the original CRT, which was a green CRT, or green phosphor on that original CRT for this particular model. So to change those profiles, I actually have that one button set up like this. So now I can go in, if I hold it down, it'll go into the menu, and I can just click it down through here, go to my profiles, change it to profile 1, and there we go. That's what it looks like as a green screen. So now we're back to the way this was really with the original CRT. And if we wanted to, we could do something that I don't believe was ever done, at least from the factory, with a TRS-80, any of the models, I don't think, which is give it an amber screen. So let's just see what that looks like. Again, we'll just change the custom profile, and there we go. Now we have a TRS-80 Model 4 with an amber screen. Now, to my eye, this looks maybe a little bit off. It's pretty close. It looks like it needs to be just a little bit more orange. Don't know how it's coming across on camera. Let me know what you think. Do you like the amber screen with this? Would this be something that would make you sit up and take notice if you went to a convention and saw a TRS-80 Model 4 with an amber screen on it? Crazy, huh? So let's go back to the green and see if we can play a game on this thing. I have hooked up my speakers back here to the cassette port because a lot of games, the way they played sound on the TRS-80, all the models, if you wanted to get sound out of them, they actually sent it through the cassette port. So I've gone ahead and hooked up a couple of speakers just so we can see. It's a very easy mod. Tons of people have done videos on it, so you can look that up if you haven't done it yourself. But let's go ahead and check out what's in disc 2. Now this would be 0, 1, and the GoTech is now 2. And here we go. This is a game called Defense Command, and I'm not sure exactly what's going on. I've noticed this on the GoTech, I think on several TRS-80 Model 3, Model 4, that they kind of have this garbage up here at the top of the screen. If you know what that is, let me know in the comments below. I'd be curious. Some of the games that I have on here, I got one to load, one didn't load. There may be some sort of communication problem with the GoTech. But anyway, I believe this game will load. At least let's try to load it and see what happens. DEF CMN 01. The thing I really like about the TRS-80. I don't know if you saw it there, but it actually, if you just type in the name of the file without the disk identifier, disk number identifier, it actually goes through the various disks. Oh, there's the sound. And it looks for that among, if you have 4 floppy disks, for example, on this, it'll go to all 4 floppy disks until it either finds or doesn't find that particular file name. It's kind of a cool feature, I think. So let's go ahead and select one player, defense command. So I don't know if you heard that, but that's pretty awesome, actually, that it could do that voice synthesis for a system that wasn't nearly as capable as the ones that came later. It's just a really cool thing that it could do. Now, I haven't played this game too much, so don't know how I'll do, but you can see it's working fine and looking fine. No problems. This is exactly what I was doing a few minutes ago when the RIFAs blew. Thank you very much. It's a little bit like a mixture of Defender and Missile Command, so I'm guessing that's where the name comes from. And then it's also a little bit like Galaga, or one of those things where they drop from above. So it's hard to talk and play at the same time, but it is kind of a really fun game, surprisingly fun game for the TRS-80. I'm not doing too well here. I believe you have to catch these guys and it'll put them back. Yeah. Ooh, almost bit the dust. Can't get that guy. Oh. Whoa, look at that. Oh, my great score went off the screen. That is so cool. Hit clear for high scores. There we go. So cool. I love that last screen with the high scores. That was probably like the best part of the game. Really cool game. If you didn't know that TRS-80s could be capable of this kind of stuff, all in text mode, now you know. Pretty cool stuff. Well, I am so excited that this thing is finally working. I've got my fingers crossed that nothing else will go wrong. Now, you may be thinking, well, Aaron, why didn't you use LDOS, or why didn't you use NewDOS 80 or something like that? That would be more period accurate for this Model 4. Well, I want to do that, but I also am kind of saving that for a follow-up episode. I'm thinking about putting a free HD in here and mounting the GoTech in the same slot here. You can do a GoTech and a free HD in one of these drive slots here. I'm thinking about doing that in a follow-up episode. If that's something that you want to see, let me know in the comments below. And it's at that point that I would also probably go through how to make drives. Now that the GoTech is hooked up, it's pretty trivial to do, actually, if you're using flash floppy. That's so cool. Like, even now, I could get those images and then create physical media if I wanted to. So I want to be able to do that. I want to create some physical media for the Tandy Model 4 just in case, and then also go ahead and install the free HD, which emulates hard drives, and GoTech in here for easy floppy image access for the Model 4. So that wraps up this episode. It was a long one. I hope you enjoyed it. If you're looking at doing one of these mods yourself, I will put the files for this bezel that I created. That's probably the most important and most difficult part of this whole thing. I'll put those files and make those available via a link in the description, so go check that out. And also, if you're interested in Tandy and Radio Shack, I'm going to put a playlist up in the corner of the screen here, so go check that out, because there's a lot of videos I've done in the past on all things Tandy. So with that, thank you very much for watching, and we'll see you later.
End of line.